Today we are talking about HDZero, and I want to share with you a clip from the interview that I did with Carl, the owner of Divimath and the maker of HDZero. I asked him to explain how the antenna inputs work on the HDZero and SharkBite VRX module. Whilst we know the original SharkBite module has 2 built-in patch antennas and 2 SMAs, and the new HDZero VRX simply has 4 SMAs, we don't fully understand how it actually selects what antenna to use, so I decided to ask him and he explained it in his own words. Before I share with you his response, I just want to say if you found this video interesting, please do consider hitting the subscribe button. If you'd like to see the full interview, there is a link to it in the description of this video. It is over an hour long and we discussed a massive amount of things around HDZero, and I do strongly suggest you check it out if you are using the system. Finally, I just want to say if you do find this video helpful, please do consider supporting the channel via Patreon as well as buy me a coffee. There are links to it in the description. Anyway, let's get on with it and let's hear how it actually works. How does the VRX choose what SMA to use? What is it? Diversity? What is the logic behind the selection of antenna?
Well, it's a little bit hard to explain. So basically, we have 4 antennas. The left 2 is a group. The right 2 is a group. So the left 2, so we have 2 OFDM demodulator inside.
Okay.
And OFDM demodulator will get the constellation data. Each one will get the constellation data. And we will, it's called MRC, is the maximum ratio combining those constellation data into one, and we decode those data into video data. So that's from the left part. And the right part do the same thing. The right part gets the video, and the left part gets the video, and the video combined in the FPGA chip.
Okay.
Right. So that's basically how the 4 antenna works.
Okay, so it's not strictly picking a 1, 2, 3, or 4. It's actually bringing all of this data in, and it's actually demodulating, bringing it right down into the RF side before combining as well.
That's right. You just can say the each pixel. Let's say each pixel maybe take like some data from one antenna and some data from the other. Yeah. So 4 antenna controls. Yeah. Every antenna contributes.
Wow.
Not like a hard switch.
No, and in the past we're used to diversity being very basic on antennas and receivers, so it's far more complex, and that, I suppose that explains why it's so important to populate all the antenna ports, because you're bringing in more data to the system.
That's right. Yeah, that's right.
Yeah, that's cool.